All right, ladies and gents, we're going to talk about how to graph using transformations. So the first thing we have to understand that's very important is the notation of f of x. What I need you to understand about f of x, it's just a notation that means function. Okay? Every function that we have will have an equation to it, and these equations turn into a drawing which we called a graph. Okay? And these functions that turn into a graph can be transformed. And the word transform means we can change them many different ways. More specifically, we can change them by transforming up and down. This is called a translation. Okay, so we can move it up or down. All right. When do we know we're moving up and down? When we take our function or our equation that turns into a drawing and we add or subtract a value to it. In this case, we call it k. Okay, so that's one way we can transform it, by translation up or down. The next way of transforming it is by translating it left or right. Okay, so we can move it left or right, and when this happens, we are going to add or subtract a number, and this number is going to be inside parentheses. The thing you need to remember is when you do a left or right transformation, or you translate it left or right, your value, in this case h, always moves from the opposite sign. So if it's negative, it's going to move in a positive direction. If it's positive, it will move in a negative direction. There's more details here. Okay? The other way we can transform a graph or change a graph is by doing what is called a vertical stretch or compression. Okay, in a vertical stretch or compression, we are actually going to multiply our function with a value, we call it a. If a is greater than 1, okay, regardless of the sign, we're ignoring the positive or negative sign. If a is bigger than 1, we call this a vertical stretch. If a is smaller than 1, okay, so that we're thinking of a fraction, we're going to compress. All right? Again, these are just rules that when we get into more examples, I will show you how this works. The other thing a can control, the a value, is if it's positive, there is no reflection. Again, reflection, if you recall, is when we mirror our graph, our drawing. If a is negative, we are going to reflect across the x-axis. What this means is when we reflect, the up becomes the down, and the down becomes the up. So in essence, think of it as a vertical flip. We're flipping our drawing vertically. All right? Next thing is we can have a horizontal transformation. And much like the vertical stretch or compression, we could have a horizontal stretch or compression. And the way this works is this number will be inside parentheses like we have here, and it will also be multiplying with the x. A common mistake is students confuse the a value with the b value. Notice the a will be outside of parentheses multiplying. The b value is going to be inside parentheses multiplying. And the rule for the b value is you always want to take the reciprocal. okay, to find the true b. That means whatever value we have, we are going to flip it, and that will give us our true b. All right? And much like our a value, if our b value is bigger than 1, we have a horizontal stretch. Okay? If our b value is less than 1, we have a horizontal compression. All right? If b is positive, there is no reflection. If b is negative, there is a reflection across the x-axis. Think of this as a horizontal flip. Okay? All right. So now that I kind of just went over briefly of what K, H, A, and B do, how do we use it mathematically? So what I'm going to highlight in purple is how do we use it mathematically. So the K value will add or subtract from your Y value. Okay, so this is a very important rule. This is how we're going to use it on our graphs. When I say Y value, I'm talking about the Y value in a point. So if you recall, every point has an X value and a Y value. So our K will add or subtract to the Y value. Okay, our H, on the other hand, remember, it's always the opposite sign. Our H will add or subtract to the X value of our point. So we'll add or subtract here. Our A value affects the graph, and the way you use it is you will multiply. Look here, you're going to multiply all your Y values, whatever your A is, we're going to multiply it with the Y values. Okay? And last but not least, once you find your true B, remember after you do the reciprocal, once you find your true B, you're going to multiply your B values with all of your X values. Okay? So again, in purple is how do I use my K, how do I use my H, how do I use my A, and how do I use my B. Again, it all seems like a lot of information here, but we're going to do plenty of examples to try to get this across. So it's very important that you understand these facts and get used to them. Okay guys, let's do our first example. If you notice, I basically copied and pasted all the rules I explained in the previous slide. And what we're going to do is we're going to graph example A after we do a transformation. So graph A, so we're going to do our graph, our function f, state the transformation. What transformation are we doing here? And then graph our new function, which we're going to call g. So before we start, let's understand what function f is. So function f is going to be the drawing. We're going to do it in red. The function that we're going to graph is actually this equation. So this is an IM1 equation. You should know how to graph this guy. Okay? So if you look, this is how we get our drawing, which we call our graph. Okay? So let's go ahead and graph x minus 2. Okay, so let's graph this. We're going to use this input-output table. Here's my input. So what x am I going to plug in here? Do the math. Once I get my output, I can put it in point form. So let's do the first one. I'm going to start with something very simple. I'm going to say x is equal to 0. So that means I'm plugging in 0 for x minus 2. Once I'm done with this, this turns into 0 minus 2. That gives me negative 2. So think of it this way. I plugged in 0 and I spit out negative 2. So how do I put that in point form? I plugged in 0 for x, and it spit out -2. I just want to remind you, the y value is the same as the f of x value. So the first point I have is 0, -2. Okay, and I'm going to repeat this a couple more times so we could get our graph. Okay, so our output table, we got this graph. Again, we could put a lot more x values and get a very more accurate graph, but just for explanation's sake, this is all I'm doing. Okay, so now this equation has turned into this drawing. What I'm going to do now is, in green, I'm going to graph g of x. But here's the kicker. Instead of doing an input-output for g of x, we're going to use a transformation. And what g of x is saying is, says, hey, take your f of x drawing, so take your graph. So just to remind you, if you look, my f of x graph is this, think of it as this line. Okay, that's a bad line. So here's my f of x graph, which is this line that you see on the graph here. And what we're going to do is we're going to translate it by adding 5 to this drawing, which might not mean a lot, but now we go to our rules up here. So if we add 5, we are actually doing this rule. We're taking our graph and we're adding something to it. This is our k value. Okay? So our k value is 5. When we have a k value of 5, since k is positive, we're going to translate up 5 units. All right, so I'll say that again. Because it's positive, that means we are translating. Translating is moving, shifting up 5 units. So what I'm going to do, instead of doing an input-output table, I'm going to shift each dot up 5 units. So it's going to look like this. So this dot here, 1, 2, 3, 4, 5. Put a dot here. This dot, 1, 2, 3, 4, 5. Put a dot here. This dot, 1, 2, 3, 4, 5. And put a dot here. So now these 3 dots have shifted up 5 units, and we have created our new graph. And this graph is called g of x. If you notice, it was basically f of x, but shifted up 5 units. Okay, so what did we do? So g of x was our drawing, and we shifted or translated up 5 units. Okay, and this is how we're going to do transformation graphs. Okay, in example B, we are going to graph f of x equals 2 of x. We're going to do an input-output table. I'm going to pick just some random x's. I'm going to keep them simple for now, and then we're going to graph it. Okay, so our input-output table. We did our input-output table. Hopefully you can follow the math here. And we end up with this line f of x. Now in green, we're going to take our function f of x, and we are going to subtract 3, but you notice it's inside, what we call inside our function, we're subtracting 3 because of the parentheses. Very different from over here where we added 5 outside of the parentheses. So when it's inside, if you look at our rules up here, when it's inside parentheses, this is left or right transformation. So that means we're going to move our graph left or right. Here's the rule you have to remember. Whatever sign you have inside parentheses, it's going to be always the opposite sign. Okay? So right now it looks like -3, but what we're really going to do is we're really going to shift +3. This is my H value. Okay, so my H value is 3. I'm going to shift +3. So what I'm going to do is take each one of my points and I'm going to shift them positively. So that means to the right 3 times. So when it's positive, we shift to the right. So if you look, I'm going to now plot each point. So it'd be 1, 2, 3 to the right, put a dot. 1, 2, 3 to the right, put a dot. 1, 2, 3 to the right, and put a dot. Connect these guys, and now we have the graph of g of x. And it's shifted to the right 3 times. Okay? All right, let's do example C. For room's sake, I'm going to do the input-output table for the f of x over here. So it's going to look like this. Okay, so here's our input-output table for f of x, and our equation for that, x squared, turns into these points. These points turn into this graph, which we call f of x. Now, I'm going to take f of x and we're going to take our drawing of f of x and multiply it by 2. So think of it this way. We're going to take our drawing and multiply that drawing by 2. Okay? If you look at our rules above, when we multiply our function by a number on the outside of parentheses, this is the a value. So in this case, a is going to equal to 2. Okay, so let's look at our rules. If a is equal to 2, we're going to have either a vertical stretch or a vertical compression. Since a is bigger than 1, we have a vertical stretch. Okay? And then we look at the sign. Is the a positive or negative? In this case, the a is positive, so that means we're not going to have no reflection. All right? So how does this look? How do we put a into our graph? Okay? So let's write down what's going to happen. We're going to have a vertical stretch by 2. So how do we do this? To do a vertical stretch, we're going to use the points. If you look at the rule says, how does a affect your graph? You're going to take all your a values and you're going to multiply with your y values. So if you look, we're going to take all our y values in our points that we have, and we're going to multiply those y values by a. In this case, my a is 2. All right, so let's do that. So I'm going to multiply 1, multiply it by 2, and the new point I get is 1 for the x. That doesn't change, but my y value is turned into 1 times 2, which is 2. Now I'm going to go ahead and plot that. 1 times 1 comma 2, which is here. Now I'm going to go ahead and do the same thing here. Times the y value by 2. What's 0 times 2? That's still going to be 0. So we get 0, 0, which is there. And then our y value here times this by 2. Notice how we're only affecting the y value. -1 stays, but 1 times 2 is 2. So it's going to be -1, 2. All right. Then we're going to go the y value by 2. That's going to give me 2, 8. All right. For argument's sake, we'll pretend 8 is up here. So 2, 8. We'll put it up here. Let me label that. We'll call that 2, 8. It's off our graph, but it'll work. All right. And then we multiply this guy, this y value by our a value. And we get -2, 8. And -2, 8 is going to be right here. And we did all the points that we have in our input-output table. So I'm going to graph the green. And the green is our g of x. And what has happened is we've used this rule. And it's very simple. It just involves multiplying your a value with all your y values. My a value is 2. And notice, it's a stretch. It looks like we stretched the parabola and made it taller. Okay? All right. This is going to go away because we have another problem here. I'm going to erase all this, and we're going to do example D. All right, example D, we're going to do the input-output table over here. Again, these x values I chose, you can choose any x values, but notice I'm choosing just basically from 0 to -1, including 2 and -2. So pretty much 5 values that are pretty simple numbers. So just in case you forgot, how do I get these points over here? I'm basically going to plug in 0 into these absolute value. So this is going to be the absolute value of 0. And if you remember, the absolute value is, in essence, we want to know the distance away from 0 on the number line. So the absolute value of 0 is actually 0. So my first point is 0, 0. All right. The absolute value of 1 is 1. So 1, 1. The absolute value of -1 is actually 1. Basically, the absolute value just gets rid of the negative sign. It turns everything to a positive, if that makes sense. So we have -1, 1. The absolute value of 2 is just 2. So it's 2, 2. And then the absolute value of -2 is 2, and we get -2, 2. All right, so I'm going to turn my equation. It turned into points, and now I'm going to turn my points into a drawing. So in essence, I turn my F into the drawing that you're going to see. All right, so my function x, or my function f, has turned into this drawing, and we did that with this input-output table. Now I'm going to take my drawing, and I'm going to apply this transformation to it. Okay, so now my drawing is getting multiplied by 3, but what you'll notice is the 3 is inside parentheses. So now when we multiply inside parentheses, this is a horizontal stretch or compression. So the keys here is we always want to use the reciprocal to get what I call the true B. So to get the true B is we take this guy, and the true B value is we're going to take 3 and we're going to flip it. So the true B value is going to be 1/3. Okay? And since 1/3 is my B value, so this is my B value, we know it's going to be a horizontal stretch or compression. So let's look. My true B value is 1/3, which means since it's less than 1, we are going to have a horizontal compression. Okay, so let's write that. We're going to horizontal compression by 1/3. Again, a compression is we're going to smash horizontally. So basically this graph is going to shrink in from left and right. It's going to go inward, left and right. Okay? So how do I apply this graph? How do I do this horizontal compression? Let's look at our rules. To do this horizontal compression, you are going to multiply your x values with your b value. Okay? Before I get ahead of myself, we always got to check the sign. Since b is positive, we also know there's no reflection. Okay? So let's do our horizontal compression. So what we're going to do now is our horizontal compression is we're going to multiply all the x values. So all these x values gets multiplied by 1/3. Okay? So let's do it. 0 times 1/3, we are going to have 0, 0. So let's plot that. No change there. And then we're going to have our first x value times 1/3. Again, it's only affecting the x value. So 1/3 times 1, you could throw this in your calculator, but I'll just do the math for you, is going to be 1/3, 1. And what does that look like? We're basically going 1/3 over, so not all the way to 1, so 1/3 of the way up 1. Okay, so again, notice how my graph is getting pulled in towards the y-axis. We're squeezing it from the sides. All right, we're going to do this times 1/3. -1 times 1/3, that gives me -1/3, 1. So -1/3, 1 is about right here. Again, it's just a little quick sketch. I'm not being totally accurate. And then we're going to go 2 times 1/3. Again, use your calculator, but it gives me 2/3, 2. So 2/3 is a little bit more past 1/3. So it's like right, 2/3 is here, 2 would be right here. So that's 2/3, 2, not quite to 1 yet. And then -2 times 1/3, and that gives me -2/3, 2, and that's going to give me this point here. Connect those dots, and what you'll notice is your graph got compressed inward from left to right, a horizontal compression.